Okay guys, so welcome. What we want to do today is take some notes. So today is 9/18 and this is graph translation. So what does graph translation actually mean? It means we're going to take a position versus time graph and we're going to show what it looks like on a velocity versus time graph. Okay, so let's take a look at the graphs that we actually already know. The first one is position, here's time, and the line would be like this. We hopefully understand that the frame of reference is our x-axis right there. And what we would say is that we have a constant positive velocity, that it starts at the frame of reference and that it moves away. We have another position versus time that's opposite of that, right? Looks like this. And when we see this, we should be thinking, oh, I have a constant negative velocity. It starts away from the frame of reference and it's moving towards. We know this because this is the negative slope. That's why it's a negative velocity. And this is a constant positive velocity because it's moving or it has a positive slope. So the slopes are indicating whether we have positive or negative velocities. Remember, this is a directional thing. So for this particular direction, it's moving towards the frame of reference. There we go. All right. We then discussed changing velocities, and I just want to show you two. So the first one, right, here's position and time, and we said that we have or can have a curve like that, and this would be changing velocities. Now, it's a positive slope, right? It's a positive slope, and this changing velocity is actually getting faster. And we know this, please remember that we want to break this up into two segments. This is slow because it's not as steep. This is really steep, and that's fast. All right? So this is actually getting faster. It starts at the frame of reference. And it's moving away. One last scenario here. Here's position, here's time. And let's look at something that starts at the frame of reference but slows down. Let's do a hard one. Let's do a really hard one. Let's do this one. This one's hard. Okay, so first of all, I have a negative velocity. I know it's negative because this is a negative sloping line. 1 minus, let's just say 10, right? 1 minus 10 is negative 9. So first of all, I know that I have a changing velocity here, and it's negative. But the question I have to ask, right? So that's a directional indicator moving back towards the frame of reference, right? So I can put towards over here. I'm running out of room. Towards. But is it speeding up or slowing down? So I break it in half, and I say that this is slow. It's a shallow slope, and this is steep, so this is fast. So it's moving towards the frame of reference, but it's getting faster. This one is also getting faster. It's moving towards, and it starts away from the frame of reference. Okay? So these are our scenarios. And in all of the scenarios, because it's position time, even in these two where we have changing speeds, this is the frame of reference, right? That's the frame of reference. So how would these look on a velocity time graph? Well, first of all, velocity time graphs look different because they have both quadrant 1, right? Quadrant 1, which is positive, and quadrant 4, which is negative. Why? Because I go over and up. These are all positive numbers. I go over and down, I get a negative number. So now we have velocity, and we'll call this in meters per second, and time in seconds. Depending on what your velocity is, maybe it's in miles per hour, okay? But the SI unit, or standard unit, is meters per second. And what we have to understand on this particular graph is that we have no frame of reference, right? The frame of reference, what our brain now perceives, right, the x-axis, this is a velocity, right? So this is actually 0 meters per second, right? So the x-axis is 0 meters per second. There's no frame of reference. It's 0 speed, right? It's got a 0. All right, so how do we put a constant, not changing velocity? Well, let's say that this is positive 1 meter per second. I have to go to my positive quadrant, and at 1 meter per second, which is 1 up, I'm going to draw my line. So there it is. This is positive 1 meter per second. Let's go to the second graph. So the second graph, once again, on a velocity time graph, I'm always drawing 2 quadrants. I'm drawing quadrant 1, which is positive, and quadrant 4, which is negative. If I look at this graph, let's just pretend that the velocity is negative 1 meters per second. Well, I know that on a velocity time graph, I have the velocity and I have time. So if my 0 meters per second is right here, right, this is 0, because that's the x and y axis where they meet. I have negative, so I have to come down here and negative. Negative 1 is right below, right, 0. So this line shows constant negative velocity. It's negative 1 meter per second. So positive 1, negative 1. Both of these graphs are showing you positive 1 meters per second. Both of these graphs are showing you a constant negative velocity of negative 1 meters per second. Okay? There's no frame of reference on our velocity graphs, but there are on our position graphs. So take note that these graphs are showing us the exact same thing. We have to look at the y-axis to know what we're looking at here. Okay, so let's come down here to the changing velocity. So once again, I'm going to draw my velocity time graph where I have a positive and a negative side. Here's velocity and time. Okay, let's pretend that this getting faster, that it's getting faster at a constant rate. I'm going to put constant rate. Well, we know that constant rates are linear. So if I'm trying to draw this constantly increasing velocity, and I know that it has a positive slope, well, this is what that would look like. Because it's getting faster, right? 1, 2, 3. It's getting faster, and it has a positive slope, so it's in the positive quadrant 1. Okay. So what this tells us, it just tells us, once again, the change in speed. The speed is getting greater. Let's take a look at the last graph here. Here's my position. Here's my velocity time. Here's a tricky one. This is my positive quadrant. This is my negative quadrant. If we have a changing velocity that's getting faster, right? Changing velocity that's getting faster, that's in the negative, my line is going to be down here in the negative side. Now, we don't want to think of these as traditional numbers. This is 1, 2, 3, 4. So as we go down, we actually get a greater magnitude, a greater number. The negative sign just means a direction over here. So that means that this line right here shows me a changing velocity, and this line is actually constant. So let's go with constant again. I'm just going to write that in here. This is a constant changing velocity, It's getting faster because it's going 1, down to 2, down to 3, down to 4 over time. So it's getting faster. And the reason it's down here in quadrant 4 is because it has a negative slope over here. It's going back towards the frame of reference. So make sure you get these notes down. I am going to take a picture of this and put it with the video so that you can have that. This should help with your concept builder.